Okay, this is the second half of the Chapter 3 review. We are going to do 3, 4, 3, 5, and 3, 7, and 3, 8. So let's start out with 3.4 here, parallel and perpendicular lines. Our first problem asks us, what is the relationship between segments AB and CD? So let's go over to our diagram and find segment AB and segment CD. Okay, we want to know the relationship between them. Well, I see two lines. Let's extend them a little bit. And they just happen to be cut by our transversal. And let's look at the angles that we have in there. So what have we got? Let's do a little redraw here. And let's take a look at this angle right here. What is the measure of that angle? Well, that's going to be 68 plus 22, and that's going to be 90 degrees. And let's take a look at this angle over here, and that's going to be 35 plus 55, and that's going to be 90 degrees. So I see two right angles, which means we have two lines that are perpendicular to the same line. So what do we get to say? We get to say that segment AB, this is segment AB here. We should label everything properly, is parallel to segment CD, because we have a theorem that says if two lines are perpendicular to the same line, then they are parallel. That's one of our perpendicular theorems. All right. What do we have next? It looks like a proof. So let's look at what we have over here. I see a couple of lines cut by a couple more lines. Got some lines and some transversals. Let's see what we can make of them. It says L is parallel to M. Actually, the first thing I'm going to do, I'm going to extend all my lines here, okay, so that I can see everybody. L is parallel to M, so I am going to mark these two lines parallel. Now that's a good thing. I have two parallel lines. They're cut by a transversal. I got two of them there. Let's see what we can do with that. We're told that A is perpendicular to L, so I'm going to make that one perpendicular. And B is perpendicular to M. So line B is over here, and it's perpendicular there. Now what do I want to happen? I want B to be perpendicular to L. So I want this right here. Is there a way to get there? Well, let's start out with our two parallel lines. We've got L and M here, and we have transversal A, and we have a right angle there. We know L and M are parallel. So what are we going to be able to say with that? We are going to be able to say that A is perpendicular to M. If you go to your notes and you find your theorem, you could find this one, and that's the perpendicular transversal theorem that lets us say that. All right, so it lets us put that in there. Right? So I'm going to come up to my diagram and add that on. So now I'm going to change to line A and line B, and then I am going to put in transversal M. And I have this and this now. And what are we going to be able to say here? Well, if we go look at our theorems and we find the one that looks like this, we're going to say that A is parallel to B, and that's the one that says two lines perpendicular are parallel. So we're just going to make a little note to ourselves there. Doesn't have to be perfect yet. And then what are we going to be able to do? So now I have these lines are parallel. So I'm going to come up to my diagram and I can make these two lines parallel. Well, is that going to let me relate line L and line B? Why, yes, it is. If we look at, we're going to be on these two lines again, A and B, and we're going to come up here to line L, right? We know that A and B are parallel. And what do we know? We can add that in, and we are going to have two parallel lines, and it's perpendicular to one. So we are going to be able to say that, I put that on the wrong side. We know that one. We want the one on the right. So we are going to be able to say this over here. We are going to be able to say that B is perpendicular to L because of our perpendicular transversal theorem. So how do we put this into a proof? Well, all of this comes down here, da 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 da. Why? It's given. You don't get to do that, I do, especially on this in the interest of time. All right, and then what did we do? We said that A was perpendicular to M, and we said that because of the perpendicular transversal. Make sure you have a V in there for transversal theorem. Makes it different from the transitive property, right? And then what did we do next? We made A parallel to B, and that was because two lines that are perpendicular to the same line are parallel. And then that let us say that B is perpendicular to L one more time because of the perpendicular transversal SV theorem. Okay, so there's our proof for that. We just worked our way around and see how our Define Explorer works for us there. Good stuff. Learn to use that. And then just match up your drawings. You redraw the section and match it up with your picture. All right, so that was 3, 4. You're going to try to make those confusing. Don't let them be. Think of them as corresponding angles and match them up with the pictures in your notes. All right, 3.5, parallel lines and triangles. These were fun. What is the relationship between line BC and line DF? Well, the first thing I'm going to do is come over here and find line BC and extend it out and find line DF and extend it out. And do you see two lines cut by a transversal? So do I. So we have got our two lines here, and they're cut by our transversal right through the middle there. And we want to do something with them. Well, what can we do? I see two triangles. And guess what else I see? I see an exterior angle there. So what is the measure of this angle? Well, we don't have another letter. AC something. What is the measure of this angle? This angle measures A plus B. Right? So I'm going to mark this angle here, A plus B. That's my triangle exterior angle theorem. Right? It says that an exterior angle is the sum of the two remote interior angles. What else do we have going? Well, look over here. I have another exterior angle, and what does it measure? It measures A plus B because there are two remote interior angles there. So I'm going to come over here and mark this A plus B. That's also the triangle exterior angle theorem. Now, do you see what we have? If you can't see it, turn your paper. I am going to be able to say, we need some letters. Label, proper labeling. This is BC. This is DF. I am going to be able to say that line BC is parallel to line DF. How come? Because of the converse of the alternate exterior angle theorem. Do you see that these two angles are congruent? The measure of this one is A plus B, the measure of this one is A plus B. They are alternate exterior angles. If alternate exterior angles are congruent, then your lines are parallel. That's the converse theorem, right? Makes our lines parallel. All right, well, that was fun. That was good use of a lot of things that we've learned. Our triangle exterior angle theorem and our converse for special angle pairs theorem. Was good. All right, what's next? We need to find the measure of angle 1. However, shall I do that? I see a triangle. We have a triangle angle sum theorem that tells me that the measures of the angles of a triangle sum to 180. So I am going to say the measure of angle 1 plus 59 degrees plus 60 degrees equals 180. So what is that? 119. Subtract 119 from both sides. The measure of angle 1 is 61 degrees. Does that look about right? Yeah, it does. Fits in nicely with those. Okay, how do we do the next problem? How are we going to find the measure of angle 1? I see the triangle exterior angle theorem. Woo! Says the measure of angle 1 is going to be the sum of my two remote interior angles. So that's 48 plus 56, 90, 114. So 114, and how could we check if that one is right? Well, we have a linear pair here. 70, that would be, what, 66 on the inside if we did a linear pair? Yeah, that matches up pretty well with our other three angles, and those would add up to 180. All right, so let's use our theorems again. Oh, we've got a lot of stuff to find out here. I think the first thing we should probably find out is the measure of angle x, and I'm going to use my triangle exterior angle theorem first that says 141 degrees is x plus 68, right? My exterior angle is the sum of my two remote interior angles. Subtract 68 from both sides. And what do I get? Oh, 71, 2, 3, 73. It's 13. Yep, that's right. So I'm going to come over here and I'm going to label that 73 degrees. And then I get to use my triangle angle sum theorem and say 68 plus 73 plus 3y equals 180. So 114, no, 141. That's 141 plus 3y equals 180. 39 divided by 3. So y is going to equal 13, and I do 3 times 13. That's funny. 3y equals 39. We had 3y equals 39 there already. So I'm going to mark this 39 degrees. Now what's another way we could have found this angle right here? Do you see a linear pair? We could have said 3y plus 141 equals 180. I was going to write that up just a little bit. I'm going to try to erase that. There we go. Let's put that in another color. 3y plus 141 equals 180, right? Linear pair postulate. Isn't that exactly the same thing we have written here? So we would get the same answer. So it doesn't matter which method you choose, whether you go the exterior angle theorem or the linear pair postulate, both will give you the same answer. All right, let's look at our next triangle. Now, the first thing I'm going to do is pick out this triangle right here. And that's the only thing I'm going to look at. Cover the other one up with your hand if you need to. And I'm going to use my triangle angle sum theorem. And it says 32 plus 46 plus x is 180. So 78. 180, subtract 78 from both sides. X equals 102. So I'm going to mark this 102. Now, how am I going to get to my other triangle over here? I am going to use my linear pair postulate right there. Right? So, linear pair postulate says that y plus 102 equals 180. Subtract 102 from both sides. So y equals 78, which you should not be surprised by that. Look, right here. This is an exterior angle, right? If we extend that side right there, that's an exterior angle, and look at my two remote interior angles. So we could have done that one multiple ways. Like I said, you're going to tend to go for the linear pair just because it's something that we use so frequently. You're going to be used to it. All right, and now I'm going to look at this triangle over here. Cover the one up on the right if you need to. And I'm going to use my triangle angle sum theorem again and do 36 plus 78 plus z is 180. So 114 plus z is 180. Subtract 114 from both sides. Z equals 66 degrees. So I'm going to come in here and put 66 degrees there. And those look like pretty reasonable numbers. All right. I love the triangle angle sum theorem. It is a ton of fun. 3.7 and 3.8. This was a pretty easy lesson, just a good algebra review that we are going to use to our advantage here for geometry. Let's see what our first problem says. On a city map, Washington Street is straight and passes through our given points. And Delaware Street is straight and passes through those given points. And we want to know if they intersect. Well, how do we know if lines intersect? Well, if lines are not parallel, they're going to intersect. So we can use our slopes. So we know that Washington Street is 7, 13, and 1, 5. And Delaware Street is at negative 23 and negative 39. I am going to find the slope of Washington Street, And the first thing I always do, x1, y1, x2, y2. I'm going to write my formula. Y2 minus y1 over x2 minus x1. And then, so the slope of Washington Street is 5 minus 13 over 1 minus 7. So that's a negative 8 over negative 6. Negative over negative makes positive. And then I reduce. I'm going to divide both of them by 2. Right? Divide by 2 and divide by 2. And that equals 4 over 3. So I know that the slope of Washington is 4 over 3. So then I'm going to look at Delaware Street. x1, y1, x2, y2. It's well worth that half a second that it takes. Delaware, slope of Delaware, y2 minus y1 over x2 minus x1. And that is 9 minus 3 over a negative 30. Don't forget this is a minus equation. Minus 20. All right, minus a minus, plus plus, right? That turns into plus. And that equals 9 minus 3 is 6. A negative 30 plus 20 is a negative 10. I'm going to divide both of these by 2 to reduce them. So that becomes a negative 3 over 5. So I know the slope of Delaware Street is a negative 3 over 5. Are our slopes parallel? No. They're not perpendicular either, but they are not parallel. So yes, the streets intersect because they are not parallel. They have different slopes. Okay. There really isn't anything special about them, but they intersect. Those streets will intersect. All right. We're supposed to graph a quadrilateral, determine if the sides of the figure are parallel, perpendicular, or neither, and explain our reasoning. So let's get to graphing here. A is at negative 2, 6. There's point A. I'm going to label it. And B is over 3 up 1. There's point B. 0, 5. There's point C. And negative 6, negative 2. There's point D. So now let's connect our lines, or our vertices, connect our vertices with lines. All right, we have a figure. So we just need to find slopes of our lines. Now this is a nice graph. Slope is just rise over run. So I can find the slope of AD, and it's just rise over run. I always go from the left, I rise, and then I run. Always work left to right and rise first. 1, 2, 3, 4, 5, 6, 7. That's 8. Positive 8. I went up 8 and over 1, 2, 3, 4. 8 over 4. So that can reduce. Divide them both by 2. Right? And that's 4 over 2. I can reduce again. I could have divided both by 4. 2 over 1. And I tend to leave my slope as a fraction because it's rise over run. And we need to look at them as fractions, right? So let's do the next one. Let's do A to B. Doesn't matter which one we do next. Now we need to rise and then run. I always work left to right. So I'm going to rise down and run over. 1, 2, 3, 4, 5. That is, I went 5 down. That is a negative 5 rise. And 1, 2, 3, 4, 5. Positive 5 run. So that's a negative 1 over 1. All right, let's just change color. Let's do B to C. And we want to rise and then run. We always work left to right, so I'm going to, that's a really poor line. Sorry about that. I'm going to rise and then run. So 1, 2, 3, 4, 5, 6 up. So 6 over 1, 2, 3. That equals 2 over 1, right? Divide both of them by 2. Do you see it? Did you see it? Do you go, oh hey, oh hey? I hope so. And the last one, we need to find the slope of DC or CD. Doesn't matter how you write it. Let's write it CD because we're going around that direction. So CD. And again, left to right. So I rise and then run. 1, 2, 3. I went down 3. And then 1, 2, 3, 4, 5, 6. I run 6. And that, I'm divide them both by 3. I get a negative 1/2. So let's figure out what's going on here. This guy and this guy have the same slope. So what can I say? I can say that AD, segment AD is parallel to segment BC, right? Because they have the same slope. So let's go over to our diagram. This line, we need red for that. This line and this line are parallel. Do you see anything else going on? What about this right here? I can say that segment CD is perpendicular to who? CD is perpendicular to segment AD. So CD is perpendicular here. And segment CD is perpendicular to segment BC. So it's perpendicular here. How do I know that? Because they have opposite reciprocal slope, right? Opposite sign, and it's flipped. Poor line AB doesn't play with anybody. But we do have 2 parallel lines and 2 perpendicular lines. All right, that was fun. Now, that is the end of the regular lesson. We did have a reference section that reviewed some things that you learned in algebra. So you can stop there. That is what is on the standard test. But if you want to go on and do a little review, we're going to do the next 2 problems. We are asked to write an equation in slope-intercept form for a line that is parallel to our given line and contains that point. So how do we do that? Well, what's the first thing we know about our given line? We know that the slope of our given line is 4 over 1. Or just 4. It's fine. What do we know about parallel slope? Lines that are parallel have exactly the same slope. So I can say that that slope is also 4. 4 over 1 or just 4 is fine. So I now have a parallel slope, and I am also given an xy point. So we're going to write that parallel. So how do I write this in slope-intercept form? Well, what's slope-intercept form? Y equals mx plus b. We need a y-intercept. We know that any line that is parallel to this line has a slope of 4. So y equals 4x, and then any b that we put in there will work. We want a specific y-intercept. This line we want specifically to be parallel and pass through this point. So I am going to substitute in my y, my m, and my x to find my variable b. So I get negative 2 equals negative 8 plus b, add 8 to both sides, and we get b equals 6. So now I have an m. I know that y equals 4x. That is any line. That is a line that's parallel to our given line. Any line that has a slope of 4 is parallel. This one in particular has a y-intercept of 6. All right, let's look at our next one. What are we given on our next one? We want an equation in slope-intercept form that is perpendicular. Anytime you see the word perpendicular, you should probably write opposite reciprocal. Okay? What is our given slope on this line? We are given that this slope is 3/1. What do we know about our perpendicular slope? Let's put red. Perpendicular slope is opposite reciprocal. So we now have a slope and an x and a y value, and then it's just the same thing we already did. All we need is a slope and a y-intercept, so let's find our y-intercept. We know y equals mx plus b. I have a given y and an m, -1/3, and an x, 6, first rule of fractions. Use the right numbers. First rule of fractions, everybody has to be a fraction, so we might as well just put him over 1 there, plus our given b. So 2 equals, these are going to cancel, get a 1 there and a 2 there, a -2/1, right, plus b. That's just a -2, so I add 2 to both sides, and b equals 4. So I now have an m and a b. This was y parallel. This is y perpendicular. Is -1/3x. We know that every perpendicular line to this line right here has that slope, and this one in particular has this y-intercept. So there we go. There's your algebra review, how to write equations of lines. Don't get confused by the perpendicular theorems. They are just corresponding angle and the converse, and match them up to your pictures. Redraw and match them to your pictures. That's what we do now, is draw and label and match stuff to our pictures to find our theorem. Triangle angle sum theorem, yay! Triangle exterior angle theorem, yay! It's a cool theorem. Make sure you know it so that you can use it when you need to. And slope, same slope, parallel. Opposite reciprocal slope, perpendicular. And that's everything. So know your slope formula, and you're good to go. Label your points, x1, y1, x2, y2. We draw, and label, and geometry is easier in color. So I am sure that if you are careful, you are going to do very well on this test.